Yes, guys. So after question number 5, let me continue with question number 5. Now, what does question number 5 say? Now, 5 says that show that the area contained between the circle r is equal to, now here it is r equal to a circle with radius a. I'll just define this. Now, in the question number 4, we were having r equal to 2a cos theta. That was also circle. I didn't explain that in detail, but I took just that area of that circle is pi a square. Okay, but if I just define that r equal to 2a cos theta, let me clarify this also. This is also circle with radius a here. And that is also circle with radius a, but center there is a0 here, center is 0, 0. Now let me define this. If I multiply this r by r in both the sides, it will be 2a into r cos theta. But 2a into r cos theta is x in Cartesian coordinates. And here this r square is x square plus y square. We know what. Okay. So what is this equation? This is x square minus twice ax. If I add here a square plus y square is equal to a square. This is nothing but x minus a whole square plus y square equal to a square. So this is the circle with radius a and center a0. On the x-axis, center is a0. Okay, this is lying on the axis of x because y coordinate is 0. So this is center of the circle and a is the radius. This a is radius here. Okay, with radius a. This was the area of this will be then pi a square because radius into pi we know that area of a circle. This was in question number 5. Now let me talk about in question number 5. Sorry, question number 4 it was. This I have defined of question number 4, which I just took that area is pi a square because radius is a. Okay, that I didn't define, but let me define now. Now question number 6, we have r is equal to a. Why this r equal to a is a circle with radius a and center 0, 0. Now here r is equal to a. R we know that what is this x square plus y square. If I square this is equal to a square, or r square equal to a square. But r square is x square plus y square. It means this is the circle with radius a and center 0, 0. Center 0, 0. And the radius r is equal to a. So this is a circle with radius a, r is equal to a. Therefore, area of this will be, area of this circle will be pi into a square. This is simple. So area of this circle is pi a square. Now it says so that the area contained between the circle r is equal to a and the curve r equal to a cos 5 theta. Now let me explain that cos 5 theta. This is a circle. What kind of a circle is? What is the figure will be? First of all, let me solve the curve. Solution here r is equal to a cos 5 theta. What kind of this curve is? This curve is symmetric to the axis of initial line. I mean, okay, this curve is the curve is here. The curve here is sorry. The curve is this is symmetric about. This is symmetric about initial line. One thing. This is symmetric about initial line. One thing. Secondly, because if I replace theta by minus theta, there is no change here in this equation of the curve. Okay, as if theta is replaced by, let me write, if theta is replaced by minus theta, the curve remains unchanged. The curve remains unchanged. So this is initial. This is symmetric about initial line. Okay, one thing. Secondly, now let me find out that what are the points here. Okay, for the limits. What are the limits for this curve? So this r, if I putting r equal to 0, we get here cos 5 theta equal to 0. That means 5 theta equal to plus minus pi by 2. This is equal to cos plus minus pi by 2. So 5 theta equal to plus minus pi by 2. This is 90 degree here. Cos 90 degree is 0. Okay, so this is therefore theta is equal to plus minus pi by 10 dividing by 5. So this pi by 2 into 5, 2 into 5 in the denominator. We are having here pi by 10. Okay, so this is theta equal to. What is mean? That means the limits for the this curve will be minus pi by 10 to pi by now this curve is here. 5 is odd number. Here 5 is an odd number. So number of loops in this curve will be 5. 5 number of loops will be there. Now let me draw the curve and the circle. It says that find the area of the figure which is contained between circle and this curve. So this is a circle here. Let me draw with radius a. Okay, and here in this case this is the initial line. Let me take initial line. Okay, this is center O here. So what are the loops here? This is one of the loops. Okay, then one of the loops is there. Okay, there are 5 loops here. Maybe 5 loops. So this is one of the loops. We have to find out the area. From this and this. This is theta here. This is d theta. P and Q point. This is, let me take A here, O, A, and let this is B here. This is x-axis initial line. O-axis is initial line. What is the area of one loop? This is so that the area contained between the circle are equal to this. If I draw a tangent line here and this tangent line, then as we have defined here, that here theta was minus pi by 10. Here theta equal to plus pi by 10. Between these two tangents, here theta is minus pi by 10 and theta equal to pi by 10, this loop is lying. Area of one loop into 5 times total area of the loops will be there. Okay, then circle area of the circle pi a square. Pi a square minus area of these 5 loops. That will be the area of difference between these two. That is so that the area contained between the circle are equal to A and the curve are equal to this is equal to 3/4 of the area of the circle. So what if the difference comes out? The difference will be 3/4 of the area of the circle. Okay, so let me find out area of one of the loops here, then total 5 loops. So area of one loop of the curve okay, is equal to, we know that this is in polar form. Area is given by, this is minus pi by 10 to pi by 10. Or if I take, let me take one loop is there, so this is twice of the, let me take this, is equal to 2 times area OAB. If I find area of one loop is twice of this half portion, and this is this. From this 0, theta equal 0 to pi by 2, pi by 10. Limit we will substitute here. This is twice into what is area OAB. This is 1.2, 0 to pi by 10. Let me write here. And here it is r square into d theta. This 2 to cancel out. One of the loops here, 0 to 10, pi by 10. And r square is this. This is nothing but a square into cos square 5 theta d theta. This is r square value. R square is from this. Let me take first equation. Okay. So now let me integrate this. So putting 5 theta. Okay. Putting here putting 5 theta, let me take equal to 5. So differentiating it with respect to 5, differentiating it with respect to 5, we get here, this is d theta is equal to 1.5 into d5. Okay, and limits, what are the limits here? That theta is equal to pi by 10, theta equal to pi by 10, phi is equal to 5 into theta, that means pi by 10 is equal to pi by 2, and at theta is equal to 0, phi is also 0, because if I put here theta 0, so 5 into 0 is 0, so phi is also 0. The limits here are, this is 1.5, let me take outside, this 1.5 here, so this is 1.5 a square, let me take outside, 0 to pi by 2 now, limits, and this is cos square phi d phi. This is 1.5 I have taken outside. Okay, so that is the value here. So what is this? 0 to pi by 2 cos square phi d phi. Now here we can apply the reduction formula. What is the reduction formula? This is 1.5 a square into 1.2 into pi by 2. This is by reduction formula. By reduction formula. By the reduction formula. Using reduction formula here. This is nothing but pi a square upon 20. 5 4 is 20. So this is area of one loop. Sorry, area of this one loop. Therefore, area of 5 loops is equal to. So area of one loop is this. This is the question number. Let me take second here. Therefore, area of 5 loops, total 5 loops. This. Therefore, area of 5 loops is equal to 5 into area of one loop, which we have just calculated. Area of one loop, that means 5 into pi a square upon 20. That means this is nothing but pi a square upon 4. Okay, this is, let me take third equation. Now area of the circle, as I calculated, that pi a square, because this is a circle of radius with radius a. So what is the area of the circle? Then the difference. Therefore, difference of, or the area contained between circle and these 5 loops. Therefore, contained area okay, between circle and the curve of 5 loops is given by pi a square, which is area of the circle. Area circle is outside, so pi a square minus, this is pi a square upon 4. So this is what? 4 pi a square minus pi a square, that means 3 pi a square upon 4. So what is this? This is equal to 3 by 4 into pi a square, that means area of the curve, area of the circle, sorry. This is area of the circle. So this we have to prove that area which is contained between these two is equal to, is 3/4 of the area of the circle. Area of the circle is pi a square. So it is proved here. Hence it is proved. So, and the curve r equal to a cos 5 theta is equal to the 3/4 of the area of the circle. Area of the circle. Area of the circle is pi a square here and 3/4 of this. So this is proved. Hence it is proved. So we can say that hence proved, or hence it is proved that area of the difference of these two is equal to 3/4 of the area of the circle. Area of the circle is pi a square. I just defined that radius is a. Therefore, area of the circle is pi a square. Now come to that is fact. Now come to the next question. And let me talk about question number 6. What does question number 6 say? Let me check it. Okay, now question number 6. It says, find the area of the loop of the curve, which is area of the loop of the curve, of a loop of the curve, yeah, of the loop or one of the loops. So this is x cube plus y cube equal to 3axy. Okay, so this is the curve here. Find the area of the loop of the curve. What kind of this loop is? Let me just talk about. Find the area of the loop of the curve here. So this we will just find out, but before that, let me define that what kind of this curve is. If I convert this into polar coordinates or polar equation, that is another point I will do that. But before that, let me define that what kind of this curve is from Cartesian form, or in case of tracing of the curve, we define this. What is this curve? If I put here y equal to x, okay, in this equation, solution, let me find out. Solution. This equation is to be converted into polar equation. That I will define, but later that I will do. But before that, let me explain that how did we trace this in case of Cartesian coordinates. So putting we see here, putting y equal to x, this equation doesn't change. The equation of this the equation remains unchanged. That means what? This curve is symmetric to the line y equal to x. So this curve is symmetric about the line y equal to x. As we see here, if I substitute x equal to y, no change. This equation will remain same. In that situation, the curve is symmetric about, okay, the line, this line, y equal to x. Sorry, this is the line y equal to x. Now, if I put y equal to x in this equation, where this curve will meet the this line y equal to x, or cut the line y equal to x. If I put here y equal to x, it will be 2. Let me take here y equal to x. It's 2x cube. Okay, because x cube plus x cube, this is also x cube, is equal to 3a into x square, because y equal to x. That means 2x cube minus 3ax square equal to 0. Or if I take x square common, this is 2x minus 3a equal to 0. Here x equal to 0 and x equal to 3a by 2. That means here is a point where x coordinate is 3a by 2. This is that point. And y, because y equal to x, y coordinate is also the same, 3a by 2. The curve is meeting the circle, this y equal to line, the line y equal to x at this point. Okay, so the loop will be like this, and this is also meeting at origin 0, 0, because x equal to 0, y is also 0. Okay, so this curve will be of this kind. Okay, here this curve is having oblique asymptote here. And what is that oblique asymptote? Here it is a, this is also a distance, and here x plus y plus a equal to 0 is the asymptote here. Is the asymptote of this curve, the asymptote, okay, which is oblique asymptote. No, parallel asymptotes of this line. There is no any asymptote which is parallel to the axis, but this asymptote is an oblique asymptote. So this is an oblique asymptote. This is like defined in case of Cartesian equations. Okay, so we have defined this. What is the area here? This is the point. Now, then we find out dy dx of this equation. Dy dx will give us that dy dx be calculated at the point this 3a by 2 and 3a by 2. At this point, it comes out to be minus 1. Okay, after solving this whole, we will get find out the slope of this line, which is tangent at this point 3a by 2, because we have calculated that there is a tangent which is making an angle 135 degree. This is 135 degree because minus 1 in tangent is tan theta is equal to minus 1. Let me take, that means 135 degree. This we defined in detail. Now let me solve it by polar equation. Finding out the area of this loop. This area of this loop we will calculate, but let me now solve it with the help of polar equations. Okay, converting this into polar equation, putting x equal to r cos theta and x equal to r cos theta and y equal to r sin theta. So what do we get? Converting this equation into polar coordinates or polar equation. Polar equation, we substitute. What we substitute here? We substitute x equal to r cos theta and y equal to r sin theta. What do we get here from this equation? This will be rq. Let me take common because it is xq means rq cos q. It will have cos q theta plus sin q theta is equal to, here it is x is also r cos theta, r sin theta. So it will be 3a into r square into sin theta into cos theta. So this is x into y. X is r cos theta, y is r sin theta, so r into r is r square. And this is r square also, rq and rq and this r square. If I divide by r square, you will get r is equal to, therefore r is equal to 3a into sin theta cos theta divided by cos q theta plus sin q theta. Okay, so this is the value of r here. Now let me find out the area of this loop. Okay, or using this, what are the limits for this equation that we will calculate? For that we have to put here r equal to 0. Okay, so this is converted into r equal to this equation. Let me write here. It implies that r is equal to 3a cos theta sin theta divided by sin q theta plus cos q theta. What we have to do, okay, now in this case, if I put r equal to 0, putting r equal to 0, this we have converted, this Cartesian equation has been converted into polar equation. Okay, putting r equal to 0 implies that this numerator sin theta into cos theta equal to 0, or sin theta equal to 0. That means theta equal to 0, and cos theta, if it is 0, then cos theta equal to, then theta equal to pi by 2 plus pi by 2 will cos theta 0, that means theta equal to pi by 2, or this is cos pi by 2. So theta equal to pi by 2, which means limits for this are 0 to pi by 2. Okay, so limits there. Now area, therefore area of the loop, of this loop here, limits we can take here 0 to pi by 2. So this is, here theta is 0, here theta is pi by 2, this along this line. So this loop, area of this loop will be, area of the loop is equal to 1.2. We know that what is the area of a polar equation. So this is 1.2, we know that 1.2 limits, this is 0 to pi by 2, in this case r square into d theta. Here it is 1.2. Okay, limits 0 to pi by 2. Here it is 0 to pi by 2 cos theta. R square is this whole cube, whole square. That means 9 a square, this one, into sine square theta into cos square theta into d theta divided by, this is sine q theta plus cos q theta whole square. Okay, so this area we have to find out. Now let me solve it further. Let me solve it now here. Okay, so this is giving us, therefore, area of the loop of this curve is equal to, this is given 1.2. Here we are calculating, okay, 1.2 into 0 to pi by 2. Here it is 9a square into sine square theta into cos square theta into d theta. I'm writing again, no problem. This is sine q theta plus cos q theta whole square. Now if I divide numerator and denominator by cos 6 theta, dividing numerator and denominator by cos raised power 6 theta. So what do we get? So we get here, let me write here. Okay, now let me rub this. So this is the curve which we are calculating. So therefore area is equal to 1.2. Now dividing by cos raised power 6, the cos raised power 6 theta. That means inside we will get cos q theta. It will be 1 plus tan q theta. And inside that, and this is 9a square that we take outside. This is 9a square upon 2. Okay, sine square theta upon cos square theta is tan square theta. Remaining cos 4 theta in the denominator will give us 1 cos square cancel out, and second is sec square theta into d theta divided by, within bracket it is 1 plus tan q theta, sorry, this is tan q theta whole square. Okay, this is the value after dividing the bracket by cos q theta, but this is square, so it is cos 6 theta. Outside it is cos 6 theta, but inside the bracket it is cos q theta. Dividing this sine q upon cos q, 1, this is, sorry, this is 1, this is tan q theta, 1 plus tan q theta in the bracket. Now let me consider further putting 1 plus tan q theta equal to, let me take t, any constant we can take it. So differentiating it with respect to t, we get, it is tan q, 1 is 0, this is 3 into tan square theta into secant square theta into d theta is equal to dt. That means tan square theta into sec square theta into d theta is equal to dt upon 3. Try to understand. This is dt upon 3. Value of tan square theta, sec square theta, d theta in the numerator. We are having this. Now limits. Sorry, here limits were 0 to pi by 2. I'm sorry. So what are the limits here? If I put here limit theta equal to, let me put at theta equal to pi by 2. Now tan pi by 2 is infinity. Infinity plus 1 is infinity. So t equal to infinity. T equal to infinity plus infinite. Okay, so this is infinity here. If I put theta 0, then t equal to 1. And at theta equal to 0, t is equal to 1 plus 0, that means 1. 1 here. Therefore limits are, the new limits, let me put here. Therefore new limits here are, here new limits are 9a square upon 2 into divided by 3 is also there. Where is 3? dt by 3. So this 1.3 will come outside. Limits, this is 1 to infinity. Okay, and this is dt upon t square. This is the final value. So let me integrate this. Now integration of this. So this is 3 3 9. This is 3a square upon 2. And integration of this is minus 1 upon t. Simple. If I take t square in the numerator, it will be t raised power minus 2. Integration will be t raised power minus 2 plus 1 upon minus 2 plus 1. That means negative 1 upon t. Putting the limits now here 1 to infinity. Okay, at infinity it is 1 upon infinity is 0. This is 0. But at 1 minus plus it will be 3a square upon 2 into plus 1. Why plus 1? Because if I put 1 lower limit, it will be negative plus. Minus is already there. When we put the lower limit, we put negative sign in between. That negative and this negative positive. 1 upon 1 is 1. At infinity, it is 1 upon infinity is 0. That will be 0. So this is only 3a square upon 2 answer. What we have to prove? We have to find out only this answer. Find the area of the loop of the curve. So this is the area of the loop of this curve. This is the answer here. So area of this loop is 3a square upon 2. This is very important. But this question is, I think, used somewhere else also. Where it has been used. Okay, it has been used, I think this is 10th question. It says prove that the area of the loop of the curve x cube plus y equal to 3axy is 3 times the area of the loop of r square equal to a square cos 2 theta. Okay, so that we will define through there. Here also the same value will be required. The area of this loop is 3a square upon 2. Okay, prove that the area in the 10th one, prove that the area of the loop of the curve this is 3 times. That means area will be a square upon 2 of this one. R square is equal to a square cos 2 theta. Area of this will be a square upon 2, and it will be 3 times of this. Okay, that will be required. That's why I've just taken this into consideration. This is the answer. Okay, so answer of this is question number 6 is 3a square upon 10. So area of this, okay, is question number 6 is 3a square upon, okay, 3a square upon 2. This I'll use here in the question number 10. Because of that I have taken this into note. Okay, now question number 7, let me talk about. 6 is done. 7th question. 7 says find the area of a loop of